The complex number z satisfy the equation given as z squared times 2 plus I minus 8iz plus t is equal to 0, where t is a real number. It is given that one root is of the form k plus ki, where k is real and non-zero. The question says find t and k as well as the other root of the equation. So let's look at how to do this. So let's call this function as function of z. So I have just copied down function of z is equals to z squared, okay, plus times 2 plus I minus 8iz plus t, okay, exactly as given. And since we already know that this is one of the roots, okay, since k plus ki is the root of the function of z, so if I substitute with this, then it should be equals to 0, right? So f of k plus ki should be equal to 0. So for z squared, which is equals to k plus ki squared, okay, 2 plus I minus 8i times z, I'm going to replace it with the root, which is k plus ki plus t is equals to 0. And then let us expand this. Okay, we can use a squared plus 2ab plus b squared formula. So k squared, okay, 2 times ki, which is equals to 2k squared I. Then we have got a k squared I squared, which is what I have written here. And this is to be multiplied by the 2 plus I minus, let's now expand, 8i times k is going to give you 8ki. And then negative 8 times positive ki is going to give you negative 8ki times I is going to give you I squared. And of course, we have got the plus t equal to 0. So there we have expanded it. So now let's substitute the I squares with negative 1. So since I square equal to negative 1, we know that only this part will have the complex part. Okay, the I will stay. But I squared is real, so I squared is going to be negative 1. Negative 1 times k squared is going to give you negative k squared. And the 2 plus I is still written as it is. Minus 8ki, this is complex, so let's keep it. So this part, okay, it would become I squared is minus 1. Minus 1 times minus 8 is going to change it into plus 8k. So that's a plus 8k, and we still have the plus t equal to 0. Now let's simplify even further. So the plus k squared and minus k squared we could cancel, and of course that's going to just leave us with 2k squared I only in the first bracket, right? So the 2k I squared, if I times by 2, is going to become 4k squared I, right? And then the 2k squared I, I'm going to multiply by the I, it's going to become 2k squared I squared. Of course, in the next step, we know that this is also going to become minus 1, and this part will become real. And then now we have the minus 8ki plus 8k plus t equal to 0. So we have the 4k squared I, and then this part, since I squared is equals to negative 1, so negative 1 times positive 2k squared would become minus 2k squared minus 8ki plus 8k plus t equal to 0. Now let's rearrange. Okay, so we have got minus 2k squared plus 8k and plus t. They are all real part of the complex number. And then let's arrange or group the complex parts together. So here we have got a 4k squared I. So I just pulled out the I. So what's going to be inside the bracket is just simply 4k squared and minus 8k, and this is equals to 0. So therefore, since the right hand side is equals to 0, of course this must be 0 plus 0i, right? So the real part of the complex number should be equal to 0, which means minus 2k squared plus 8k plus t is equals to 0. And the imaginary part should also be equals to 0. That means 4k squared minus 8k should also be equal to 0. So if this part, if I were to factorize it, okay, 4k squared minus 8k equal to 0, if I factorize by pulling out a 4k, so I get a 4k times k minus 2 equal to 0, and either k is equal to 0 or k should be k minus 2 should be equal to 0, in which case k would become 2. Now Take note that k equal to 0 is rejected because you are told that k is real and non-zero. It's not 0. So k equal to 0 is rejected, and therefore k is equals to 2. Now if I were to take k equals to 2 and substitute into the real part, which is here, so we can find the value of t. So since k equals to 2, so let's replace all the k's in the real part with 2 minus 2 times 2 squared plus 8 times a 2, that's what I have written here, plus a t, okay, is equal to 0. So now let's evaluate this. 2 square is a 4. 4 times minus 2 is going to give you minus 8. And then this is 16. 16, you subtract 8, it's going to give you 8 plus t equal to 0. And that, if you solve it, your value of your t should be equals to negative 8. So that is the value of t. So there we have the values of t and k as needed by the question. And we are also told to find the other root of the equation. So let's find the other root of the equation. So we have gotten all these values, t equals to negative 8. And if I were to substitute t equal to negative 8 into the equation, so the equation now becomes fz is equals to z squared 2 plus I minus 8iz. I've just copied down. Only that t I replace with minus 8. So that is the function of z. So since k is equals to 2 into the given root, okay, this was the given root, right, and we can factorize it. So fz would be equals to, okay, 2 plus I times z minus, since this is one of the roots, so 2 plus 2i. So I have just replaced the k with a 2, right? So k plus ki, if it is a root, that means 2 plus 2i is one of the roots. And I do not know what is going to be the other root, so I am just going to simply leave it as z minus p. So where p is something that I need to find out, and that would be the other root of the equation. So now we can compare the constants together, right? So what would be the constant? 2 plus I, and I will multiply by this constant here, which is 2 plus 2i, okay. Of course the minus and the minus is going to become plus, so that's why I have ignored it. So 2 plus 2i times p. So can you see that? I took this number, multiply by 2 plus 2i, multiply by the p, and all this is equals to 8, okay, which is the value of t, okay. So this is equals to 8. Now from this we can actually find the value of p. So if I were to expand this, so 2 times 2 is a 4, okay, 2i plus another 4i is going to become 6i. 2i times I is going to be 2i squared, and of course multiplied by p is equals to negative 8. So 2i squared would be negative 2, right? So 4 minus 2 is going to become 2, and the 6i is still there, times p is equals to minus 8. So if you want to find just the p alone, so you can throw this 2 plus 6i over to the other side and divide the minus 8 by the 2 plus 6i. And of course, in order to convert it into a complex number, so we have to rationalize it by multiplying the numerator and denominator of p by the conjugate of the denominator, which in this case is 2 plus 6i. Its conjugate would be 2 minus 6i. So let's expand the numerator. Negative 8 times 2 is going to become negative 16. Negative negative is going to become positive. 8 times 6i is 48i. Now for the denominator, we have 2 plus 6i and 2 minus 6i, and of course 2 square is going to become 4, okay, plus minus is going to become minus 36i squared, and because of the I squared, the minus 36 would now turn into a plus 36. So the denominator would of course be 40. So now we can split this up into minus 16 over 40, which is going to give us negative 0.4, and 48 over 40 is going to become 1.2, and there we have the value of p, which is basically the one other root of the equation which we were asked to find. Therefore minus 0.4 plus 12i is the second root of the given equation.